All right, so I have limited whiteboard space here. So let's first take a look at the precise definition of a limit. So the limit as x approaches a of some function is equal to L if the absolute value of f minus L is less than epsilon when the absolute value of x minus a is less than delta. So let me just explain this. So when we have an a, we're approaching a, some x value. As we're approaching a, the limit, if the limit exists, as we get closer to a, the y value is going to get closer to L. Yeah? So in order for that to happen, the absolute value of our function, so if I pick an x value over here, f of x is over here, and f of x minus L, that distance has to be less than epsilon. So this distance is epsilon. I added some amount to L, some number epsilon, and subtract the same amount. So this is what's called my epsilon neighborhood, all right? So this is, that's the idea here. And when the absolute value of x minus a is less than delta, so if I'm in, this distance is delta. So when I'm in here, if I go up and over, I'm going to land in that epsilon neighborhood. Notice if I'm outside of this distance, more than this distance of delta, if I'm over here and I go up and over, I am not inside that epsilon neighborhood anymore, all right? So in these problems, there's two graphs, and we're asked to find what is delta, all right? So let's try to understand what I just explained. I know this is a little abstract, but let's first take this. All right, so if x plus 1, the absolute value is less than delta, well, the form is x minus some number. So the number here we're talking about, a is -1, because x is, we could think of this as x minus a minus 1. So when we're at -1, f of x minus 2, well, 2 is what the limit is we're approaching -1. Our y value is 2. But we want that distance to be less than 1. So what we do, our epsilon now is 1. That's our value of epsilon. So we take our limit, which is 2, right? That's our L. That's 2. And our epsilon in this case is 1. So what we do is we add 1 to 2. That takes me up here. And subtract 1. So this is my epsilon neighborhood. Now, go over to your graph and down to the x-axis. Okay? So now notice, this is -1. This is the limit that we're going to. What you want to do is you look at the left side of your -1, and you look at the distance on the right side in this neighborhood. And you want to pick the smaller of the two distances. This distance is 1, this distance is 2. 1 is clearly smaller than 2. So the answer here, the value of delta for part 1 is 1. It's not showing up very good. Let me use a different color. So delta is equal to 1. Now why does that work? Because let's say delta is 1.5. If I go 1.5 to the left, that's right here, and notice when I go up to my graph and over, I am not inside that epsilon neighborhood. But if I don't go any more than 1 away from our a value of -1, if I'm less than 1, when I go to my graph and over, I remain in my epsilon neighborhood. Go to my graph and over, I land inside that neighborhood. That's the reason why you pick the smaller of the values. Here it's the same thing where a is -1, our limit is 2, but now epsilon is 2. So the limit, our y value is 2, and our epsilon is 2. So we go up 2 and down 2. And then we do the same idea. At the upper epsilon value up there, go to your graph and down, and do the same with the bottom value. Go to your graph. Well, we're already at the x-axis, so that's it. So now this is my -1. Look at the distance to the right and the distance to the left. Clearly this distance is smaller than this. This is 4, this is 2. 2 is smaller, so the value of delta is 2. Notice as long as I don't get more than 2 away from this value of -1, when I go up to my graph and over, I will be inside that epsilon neighborhood that's in green. It's going to work out. But if I go more than 2, 3, and when I go down and over, I am not inside that neighborhood. I'm outside that epsilon neighborhood. So that's the reason that's 2. Now let's do an example where the graph isn't a straight line, but it's the exact same concept. So, you know, I'm just going to do, well, all right. So what is our limit here? Well, keep in mind the form is x minus a, so this is really x minus a minus 2. So this is the limit we're talking about. A is -2. A is -2. When we're approaching -2, our limit, our y value must be 3. So when we go up and over, yeah, this is our L, which is its value is 3. Now our epsilon in the first example is 1. So we go up 1 from our limit L3, we go up 1 and down 1. Go to your graph and down, go to your graph and down. Look at the two distances relative to our -2. This distance is 2, this distance is 1. 1 is smaller than 2, so the answer here, our delta value has to be 1 or smaller. Notice again, as long as I'm no more than 1 away from -2 when I go up and over, I land in that neighborhood. But if I'm more than 1, let's say 2, 1, 2, 3, when I go up and over, I am not inside that epsilon neighborhood anymore. So it's the same idea. This is the same thing. We're approaching -2. Our limit is 3. But now our epsilon value is 2. So starting here, starting at 3, we go up 2 and down 2. Now that's our epsilon neighborhood. So go to your graph and to the x-axis. Well, I'm at the graph, so I just go down to 0. Go to my graph and down. Look to the left and right of my limit. X is -2. This distance is 2. This distance is 4. 2 is less than 4, so the value of delta here is 2.